Hi there, welcome to our video for ordinary level Leave Cert Maths. We're going to continue with patterns and now look at non-linear patterns. So quadratic sequences and exponential or geometric sequences. 1, 4, 9, 16, 25 is a sequence of numbers. To find out what type of sequence it is, we'll examine the differences. So I've listed out term 1, 2, 3, 4, 5 of the sequence. The first difference between the first two numbers 1 and 4 is 3. Between 4 and 9 is 5. Between 9 and 16 is 7. 16 and 25 is 9. 25 and 36 is 11. And 36 and 49 is 13. So we see that the first difference is not constant. It's changing each time. So this is not an arithmetic sequence, or it's not a linear sequence. They're arithmetic and linear is the same. So we go to the second difference, which is the difference of the differences. Between 3 and 5, we have a difference of 2. Between 5 and 7, the difference is 2. Between 7 and 9 is 2, and 9 and 11 is 2, and 11 and 13 is 2. So the second differences are constant. So that means it is a quadratic sequence. In a quadratic sequence, the second difference is constant. The general form for a quadratic sequence is Tn equals an squared plus bn plus c, which is very similar to the general form for a quadratic equation, which you would remember as ax squared plus bx plus c. So I just replaced the x's with n's because we're talking about patterns. A in this general form is half the second difference. And at ordinary level, they will give you that in the question. Here's an example. 3, 4, 7, 11, 19 is a sequence. Find the next 3 terms of the sequence. Okay, so we go 3, 4, 7, 12, 19. We continue on the pattern starting at the bottom with the second difference. So there's going to be 2, and then another 2, and then another 2. And filling in, above that, 7 and 2 is 9, 9 and 2 is 11, 11 and 2 is 13. And for the top row, 9 and 19 is 28, 28 and 11 is 39, 39 and 13 is 52. So there is how we extend the pattern. Start with the bottom with what's constant and work your way back up towards the top of the sequence. Finding the general form of a quadratic sequence. So they might give you the sequence and ask you to find the formula for it, the general form. So again, write out your sequence, find your first difference, find your second difference. That's your starting point. The difference between 3 and 10 is 7. Between 10 and 21 is 11. Between 21 and 36 is 15. And then the difference between 7 and 11 is 4. And 11 and 15 is 4. So the second difference is the same. It is a quadratic sequence. And the A is half the second difference. So the first part of our general form, A is going to be 2, half the second difference. And that will be given to us here. Now what we need to do is we need to fill in 1 for n. And we know that the first term in the sequence is 3. So we can fill in 1 for n, let it equal to 3. Okay, so now we have b plus c equals 1, and we'll call that our first equation. We then do the same thing with term 2. We know that term 2 is going to equal 10, so now we fill in 2 for n and let it equal to 10. Now we have a second equation, 2b plus c equals 2. 2 unknowns, b and c, and 2 equations. So we have what's called simultaneous equations. We set these up on top, one on top of the other, and then we're going to have to add the lines to cancel out one of our unknowns. Solving for b, we get b equal 1, And now we'll bring down one of our original equations and sub in 1 for b and calculate c. We found c to be 0, so out to the side, nice and clear, I'll write a as 2, b is 1, and c is 0. Then going to our general form, Tn equals an squared plus bn plus c, I'm going to fill in a, b, and c. So Tn becomes 2n squared plus 1n plus 0, which tidies up nicely to be 2n squared plus n. And that's the general form for that quadratic sequence. If you fill in any term number for n, it'll tell you what term value that is in the sequence. Exponential sequences are also known as geometric sequences, and they are where a number or a term is multiplied by a common ratio r to find the next term. So I have 3 examples of geometric sequences here, also known as exponential. 2, 6, 18, 54, 162. That's a geometric sequence because each number is being multiplied by 3. 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54. In pink, 1, negative 5, 25, negative 125, 625. This sequence is alternating from positive to negative, because it is being multiplied by a negative number every time. And it's being multiplied by negative 5. To find out that common ratio, what you do is take any 2 terms and divide them. So if I divided negative 5 by 1, I would get negative 5. If I divided 625 by a negative 125, I would get negative 5. So that's a fast way of finding a ratio. Take 2 terms, one after another, and divide them. 120, 24, 4.8, 0.96, 0.192. That ratio is 1/5. So each term is being multiplied by 1/5. So it's getting smaller every time, getting closer and closer to 0. Before we finish, I'm going to show you an alternative method of finding the general term of a quadratic sequence. A is half the second difference, which is the same as before, but then 3 times A plus B is the difference between the first and second term. So term 2 take away term 1. The difference between the first and second term there highlighted in yellow. And A plus B plus C is the first term. Because if you were to sub in n equals 1 into the general term, it would just give you the first term. So if we've done our sequence as before, where we have first difference, second difference, we can pick out these values quite quickly and we don't have to use a simultaneous equation. Right, we found A to be half the second difference, so A is 2, and then 3A plus B is the difference between the first and second terms. So in this question, 3a plus b is going to equal 7. We know a is 2 from the first part, so we'll replace a with 2 plus b equals 7. 6 plus b equals 7. B equals 7 minus 6. B equals 1. And now using our information of a and b, we can fill into our last equation, where a is 2, b is 1, and c, and from above we were told a plus b plus c equals the first term in the sequence, which is 3. So here we have 3 plus c equals 3, c equals 3 minus 3, c equals 0. Filling in a, b, and c into the general term then, Tn equals 2n squared plus 1n plus 0, which simplifies nicely to 2n squared plus n, which is the same as what we had before. Now, this one is nice because you don't have to use the simultaneous equation, but if you forget what these 3 terms are, you can't even attempt the question. So, a lot of risk there. I would be advising maybe for 5th year, this one would be acceptable, but for 6th year, when you're more comfortable with simultaneous equations, you would go back to the first method. That's nonlinear sequences. Hope you found it useful.